स्टूडेंट नहीं है? नहीं. Started. So in the last lecture we were discussing currents of Pacific Ocean, and there I was discussing about counter current and its impact. So what I told you that basically counter current is the result of piling up of water. Counter current is the result of piling up of water on the western side of Pacific Ocean by north and south equatorial current. North, and because the expanse of Pacific Ocean is huge, to the extent over which these trade winds blow is like huge. So north and south equatorial current of Pacific Ocean lead to huge piling up of water on the western side. As a result, slope gets formed and a strong counter current. Because of the slope, a strong counter current gets generated. This counter current is far more stronger than the counter current of Atlantic Ocean. The temperature of counter current is more than north and south equatorial current. Why? Because these two currents, north and south equatorial current, lead to piling up of surface warm water on the western side, and as a result the slope gets formed. This warm water moves towards east, so counter current, its temperature is more than either north and south equatorial current. Now during northern summers, when pressure belts, wind belts, ocean current all shift northward, this northern summer month of June, the counter current also turn north, and the cold Peru current, which flows along the western coast of Peru, this cold Peru current also crosses equator and meets counter current north of equator every year. Every year during southern summers, that is in the month of December, all the pressure belts and wind belts shift southward. In the month of December, that is southern summer, all winds and currents shift southward. This counter current also turns southward, and guided by the projecting coast of South America, this warm water of counter current moves south. Every year. This happens every year. So every year what we see? Two types of water along the eastern Pacific Ocean, that is along the coast of South America, you find two types of surface water. Warm water of counter current moving from north to south, and cold Peru current moving south to north. And this counter current is found on the right hand side of Peru current. Two different types of water along the eastern coast of Pacific Ocean, or you can say along the western coast of South America. Two different types of surface water are found, cold and warm. This is an annual phenomena. In certain years, for reasons unknown, nobody knows the reason, and so-called Indian scholars also do not know the reason. By whatever I am teaching, you have to, it is acceptable in UPSC, although not at international level as of now. I will also tell you what is accepted at international level. इस एग्जाम को क्रैक करना है तो यही लिखना है, जो कि एकदम फालतू बकवास है. लेकिन it is not accepted internationally, but this exam demands this. This is what it is accepted in this exam. Now, in certain years, for reasons unknown, this counter current becomes exceptionally strong, very warm. So much so that it raises the temperature of east surface water of East Pacific Ocean to such an extent that this Peru current completely disappears. This phenomenon is also known as sea fever. In those years, when counter current is exceptionally strong, this counter current warms up the water of East Pacific Ocean, Peru current disappears. In those years, counter current is known as El Nino current. पूरी इंटरनेट पे तुम मुझे कहीं एलिनो करंट शब्द ही दिखा दो. एलिनो इज अ मेट्रोलॉजिकल फिनोमिना और मेट्रोलॉजिकल इवेंट associated with the warming up of surface water of East Pacific Ocean that impacts the rainfall over half of the world. El Nino is not a current, पहली चीज. लेकिन यूपीएससी में लिख सकते हो, क्योंकि यूपीएससी और इंडियन स्कॉलर्स ये सही मानते हैं. El Nino as a counter current in those years when it is exceptionally strong is known as El Nino current. Otherwise, El Nino is a meteorological phenomena, a meteorological event associated with the warming up of water of East Pacific Ocean that impacts the rainfall over half of the globe. That is the precise definition. लेकिन अब इंडिया में है तो तुम you can write, you should write, yes, it is accepted. Those years a counter current is known as El Nino current. It warms up the water of East Pacific Ocean. इसके और impact भी पड़ेंगे. And it extends far to the south of South America, crosses Cape Horn and continues its journey. This event happens in December and continues its journey along with South Atlantic Drift, and by the month of June it reaches South Indian Ocean. June is the month of monsoon, where low pressure is established over Indian subcontinent, northwestern part of Indian subcontinent because of intense heating. Winters is in southern Indian Ocean, so high pressure is there because of cold water. This warm water of El Nino current reaches over here and warms up this water. When this southern Indian Ocean is warmed up, this high pressure lowers down, and when this high pressure lowers down, the southeast trades becomes weak, and southwest monsoon becomes weak. This is what it is accepted in India, and you can write in UPSC. What is accepted at international level? ये तो यूपीएससी में लिखना ही है तुमको, लेकिन what is the view of international scholars? What do they say about El Nino? Now, see, there was a head of India's meteorological department, British observatories in India, Walker. On his name, a cycle was named Walker circulation. I'll discuss this. So, Jerknes, when he studied Pacific Ocean, he found that in Pacific Ocean there's a Walker circulation. He named it Walker circulation after Gilbert Walker, who happened to be the head of British observatories in India. Now, what is actually found in Pacific Ocean? In Pacific Ocean, it has been found in normal year. In normal year, the pressure, this is the equator, this is equator. In normal year, the pressure winds always blow according to pressure gradient. In a normal year, the pressure gradient in Pacific Ocean is directed from east to west. As a result, winds blow from east to west. Winds blow from east to west. Winds always blow according to pressure gradient. In a normal year, the pressure gradient in Pacific Ocean is directed from east to west. So on the surface of the ocean, you find easterly winds. Surface, easterly. If it is East Pacific Ocean, this is West Pacific Ocean. On the surface, you will find surface easterly winds. These winds drag the warm surface water on the western side of the Pacific Ocean. When they reach western side of Pacific Ocean, they encounter this topography, Great Dividing Range and other topographies of Indonesia, and these warm moist air is forced to rise because of topographic obstruction. They are forced to rise. When this warm moist air rises, it causes heavy rainfall along the eastern coast of Australia, Indonesia and Papua New Guinea. Heavy rainfall. Moreover, sea surface temperature of West Pacific Ocean is 8 to 10 degree higher than East Pacific Ocean, warm water. It is warm water, as well as piling up water leads to rise in sea level. And because of numerous ocean bottom topography in western part of Pacific Ocean, there are numerous ocean bottom topography, sea mounts, gyots, oceanic ridges, islands, which provide a very suitable platform for coral reefs. And the climatic condition, warm water and raised sea level, is even more conducive for proliferation of coral reefs. So coral polyps or coral reefs are found in abundance, and heavy rainfall ensures ample sugarcane cultivation, milch cattle, and basically this area is lush green. Once this air rises after reaching the middle troposphere, it turns towards east. That is, after rising, it turns towards east, and on reaching the eastern part of Pacific Ocean, it again sinks down. In the upper atmosphere, after causing rainfall in Australia, Indonesia, it turns towards east and again sinks over eastern Pacific Ocean, that is western margins of South America. This sinking lowers sea level. This sinking doesn't allow rainfall. So we have Atacama Desert. On the surface, after sinking, when these winds blow towards west, this lead to huge upwelling after sinking. As the wind will again move towards west, surface easterly, it will drag the warm surface water, and cold water will upwell from below. Upwelling of cold water. Upwelling of cold water. This ensures abundant planktons. So fishing is thriving. Fishing. Fishes are found in abundance. Here, this ocean atmospheric circulation found in Pacific Ocean was named as Walker circulation. When Jerknes, the scholar who named it was Jerknes. He named it, he was the person who studied this, found this oceanic circulation, and he named it after George Gilbert Walker, who was the head of Indian observatories because of his contribution. So initially it was thought that Walker circulation is confined to Pacific Ocean. Subsequently, it was found that similar oceanic atmospheric circulation are not only confined to equatorial Pacific Ocean, rather they are also found in Indian Ocean, of Africa, Atlantic Ocean. Then the term Walker circulation was applied for, in general, for all these ocean atmospheric circulation that take place in equatorial waters. Now, this was the view of Walker. Normal condition, this prevails. To find out the strength of Walker circulation, a Southern Oscillation Index was developed. By how much strong the Walker circulation is, what is Southern Oscillation, strength of Southern Oscillation, strength of Walker circulation. A Southern Oscillation Index was developed. Southern Oscillation Index कैसे डेवलप की गई? A representative station, Tahiti was taken to be the representative station of East Pacific Ocean, that would reveal the temperature of East Pacific Ocean, pressure of East Pacific Ocean. And Darwin, north of Australia, was taken to be the representative station of West Pacific Ocean, that would reveal the temperature and pressure of West Pacific Ocean. Using these two, a Southern Oscillation Index was developed. That is, it was calculated by subtracting pressure at Tahiti minus pressure at Darwin would give you Southern Oscillation Index. Now, since in a normal year, surface easterlies are found because of pressure gradient is directed from east to west. So in the eastern part, upwelling of cold water is there, Peru current is there. Cold water means high pressure. And this warm surface water piles up on the western side. The western side of Pacific Ocean would have low pressure, warm water and low pressure. So pressure at Tahiti in a normal year is always more as compared to Darwin, which represents the West Pacific Ocean. Because of piling up of warm water, the pressure is low. And when this pressure at Tahiti is more, that means Southern Oscillation Index is positive. We keep a track of this Southern Oscillation Index. +1, +2, +3, +4, +5, +6, +7. +7 means the Walker circulation is very strong. When this Southern Oscillation Index is +7 consistently for few months, then we say La Nina has occurred. La Nina, if it is very strong, these cumulonimbus clouds will cause copious precipitation, copious rainfall over Australia, Indonesia, and basically sinking air will ensure drought condition in western part of South America. But fishing will be thriving, and here coral reefs will be thriving. La Nina ensures a good monsoon. I will explain it soon. Now, what happens in certain years? This is the normal condition. In certain years, when reasons unknown, international scholars do not say this counter current turns southward, it is strong. No, they say for reasons unknown, the water in the eastern part of Pacific Ocean warms up. कोई भी reason हो, maybe counter current or whatever it is, the water in the eastern part of Pacific Ocean during El Nino years, it gets warm. In eastern Pacific Ocean, it warms up. When it warms, the water in East Pacific Ocean warms up, what happens? When this water will become warm, automatically low pressure will come into existence. When this low pressure will come into existence, the pressure gradient will get reverted. Because of low pressure, now here low pressure is there, because of El Nino, warm water in the eastern Pacific, surface water of East Pacific Ocean gets warm. The surface winds always blow according to prevailing pressure gradient. As a result, the easterly winds are replaced by surface westerly. Now, during El Nino year, it is east. यहीं पर मुझे दूसरा भी समझाना है, ऊपर बना देते हैं. During El Nino year, East Pacific Ocean, this is West Pacific Ocean. The surface winds are westerly. As a result, what we see, huge rainfall takes place along Atacama Desert. Desert एकदम green हो जाता है, बनाना और कोकोनट लोग करने लगते हैं. It copious rainfall because this warm moist air will encounter Andes and it will cause heavy rainfall. After causing heavy rainfall by way of cumulonimbus cloud, second, heavy rainfall along western part of South America in Atacama Desert, plus warm water. The surface winds will, this warm water is there. Warm water, sea level gets raised. Sea level in the eastern part of Pacific Ocean is raised because of piling up of water. All have impact. Heavy rainfall, warm water, this warm water lead to disappearance of planktons. So fishes, planktons happen to be the food for the fish. Fishes disappear, खत्म हो जाती हैं. guano disease appear, other pest disease also appear, fishing गायब, heavy rainfall हो रही है, but fishes disappear. After causing, once it encounters the Andes and rises, it causes rainfall. Then again it turns towards left. In middle troposphere, it turns towards left, towards Australia. And sinking takes place on the western side. After rising, it turns towards left, and sinking takes place on western Pacific Ocean. As a result of sinking, sea level is lowered, drought in Australia, northern and northeastern part of Australia. Basically, intense evaporation, because sinking air prevents cloudiness. Sinking air ensures abundant sunshine. Abundant sunshine ensures abundant loss of moisture. A huge loss. Sugarcane farming is adversely impacted. Intense evaporation, drought-like condition, and because of lowering in sea level, apart from lowering in sea level, the surface winds which blow eastward lead to upwelling of, when the surface wind will move eastward, they will drag away the warm surface water, and as they drag away the warm surface water, cold water upwells from below. Here upwelling of cold water takes place, that and lowering of sea level. This leads to coral bleaching on large scale. El Nino is one of the factors that has led to coral death. Coral reefs are very important. Coral polyps absorb sufficient amount of carbon dioxide. As a result, they contain global warming. And once coral reefs are destroyed, the pace of global warming will become alarming. Coral polyps represent a very fragile ecosystem. Up forests are being cut, so surplus carbon dioxide is being dissolved in ocean. Oceanic water is becoming acidic, so marine ecosystem productivity is decreasing. These coral polyps absorb the carbon dioxide from the ocean and maintain the marine ecosystem. So coral reefs are destroyed. El Nino contributes to a large scale to global warming, although it is a natural phenomena, and until now we do not know the exact cause of El Nino, but it leads to large scale death of coral bleaching, and contributes to global El Nino years accompanied by intense global warming. Now coral bleaching takes place on large scale. Now usually when it happens, it does not happen abruptly. Suppose this was Walker circulation, right? It intensifies. We make use of Southern Oscillation Index to know whether what is the condition of Walker circulation. If Southern Oscillation Index is negative, this means Walker circulation this is not Walker circulation, this is Walker circulation. This Walker circulation starts becoming weak and it reverses. Negative means -1, -2, -3, -4, -5, -6. When it is -7 consistently for a few months, then we say El Nino has taken place. Color of background. कहाँ गया वो? अरे color of background. अभी यार मुश्किल में डाल दिया. Settings. अरे you white background. अंशुल, इसका कलर देखना है, इसका कलर चेंज करना है, मैं भूल गया, बहुत दिनों से कलर ही नहीं चेंज किया. कलर अब बेटा नेक्स्ट क्लास में चेंज कर देंगे, अभी मैं ठीक है, नेक्स्ट क्लास में वाइट कर देंगे इसको, विल मेक इट. So what we saw, this is reversal of Walker circulation. Reversal of Walker circulation. Now, such oceanic atmospheric circulation is not only confined to this Pacific Ocean. They continue in large part of equatorial waters. Now, in normal year, when I told you this, this is the oceanic atmospheric circulation taking place in Pacific Ocean. Normal year, rising air is found on the western side of Pacific Ocean, then it turns east. Subsequently, it was found it also turns towards west. After rising, it also turns towards west. In a normal year, sinking air is found over southern Indian Ocean. Sinking air is found over southern Indian Ocean, and sinking air intensifies high pressure over southern Indian Ocean. As a result, normal year monsoons are normal because the air is sinking over southern Indian Ocean. Now, this air is sinking in this sinking air intensifies high pressure, and this high pressure ensures that the monsoons will be good. And if it is La Nina, in that case, this Walker circulation is very strong and this sinking is very intense. As a result, the pressure over southern Indian Ocean is very high, which ensures very good monsoon. And in the eastern side, where the air is sinking, after sinking, I told you it turns towards west. Not only west, after sinking, it also turns towards east. After sinking in West Pacific Ocean, it turns towards west. It also turns towards east. And rising air is found in western part of Atlantic Ocean. After sinking, it turns toward east, and rising air is found in western part of Atlantic Ocean. As a result, this is the region where hurricanes takes place, and the rising air further intensifies the number, frequency and strength of hurricanes. Normal year is not a wanted year in USA and Caribbean islands, because in a normal year, after sinking in West Pacific Ocean, it will also turn eastward, and rising air is found in West Pacific Ocean. This rising air gives birth to numerous hurricanes. The intensity, frequency and strength of hurricanes is very high. As a result, lot of destruction is caused. So normal year is not at all welcome in US and Caribbean islands. Whereas in El Nino year, reverse happens. Because of warming in East Pacific Ocean, surface easterlies are replaced by westerlies, and the Walker circulation is reversed. As a result, sinking in the western part of Atlantic, after sinking in western part of Pacific Ocean, wind also turn towards east as well as west. And in southern Indian Ocean, rising air is found. Here in southern Indian Ocean, rising air is found, which is conducive for rainfall in southern Indian Ocean. But rising air lowers the pressure over southern Indian Ocean. Rising air lowers the pressure over southern Indian Ocean. As a result, the southeast trades become weak and southwest monsoons become weak. Whereas here in the eastern side of Pacific Ocean, where rising air is found, after rising, it will not only divert towards west, it also moves towards east and sinks over West Atlantic Ocean. in El Nino year, it sink over West Atlantic Ocean. As a result, frequency, intensity and number of hurricanes is very less. And it is a welcome. El Nino year is a welcome year in USA and Caribbean islands because loss of life and property due to hurricanes is very less. So this is what is accepted at international level. This is, and basically what you can write the view of Indian scholars as well as this view. This is more acceptable. In monsoon, Indian monsoon, while I will also discuss more elaborately what is El Nino, Modoki, what is the impact of basically what is Indian Ocean Dipole, how Indian Ocean Dipole negates the impact of El Nino or La Nina or El Nino Modoki, and basically what is how subtropical westerly jet stream, tropical easterly jet stream impacts Indian monsoon, creates Indian monsoon, and how these in Indian monsoon we'll discuss in a more elaborate manner, right? So this was the effect of ocean current in different parts. So this El Nino is a meteorological phenomena. It is said to be this meteorological teleconnection. El Nino occurs in December, monsoon occurs in June. They are separated by thousands of kilometers, but still they affect each other. So this is known as meteorological teleconnection. Two meteorological events taking at different places at different point of time, but still impacting each other is meteorological teleconnection. What is southern oscillation? During normal year, when the surface winds are easterly, water piles up on the western side as the sea level in the western side of Pacific Ocean gets raised, and the eastern side, because of sinking of air, sea level is lowered. Whereas in El Nino year, surface westerlies come into existence, so water piles up on the eastern side of Pacific Ocean, the sea level of equatorial East Pacific Ocean gets raised, and the sinking air in the western side of Pacific Ocean, the sea level of western Pacific Ocean gets lowered. So this oscillation, during normal year, the sea level of West Pacific Ocean is higher as compared to East Pacific Ocean, but as soon as El Nino takes place, it gets reversed. Sea level of East Pacific Ocean gets raised and sea level of West Pacific Ocean gets lowered. So it is known as southern oscillation. And the official name for El Nino is ENSO, El Nino Southern Oscillation. It is El Nino that causes southern oscillation. अगर El Nino कभी नहीं आता तो sea level हमेशा ऐसे ही रहता, Eastern Pacific Ocean का low, Western का high. But it is because of El Nino that it gets reversed. So this southern oscillation is reversal in the level of the equatorial East Pacific Ocean and equatorial West Pacific Ocean. The sea level of equatorial East Pacific Ocean and equatorial West Pacific Ocean changes. This is known as southern oscillation, and the official name of El Nino is ENSO, El Nino Southern Oscillation. So this was about impact of counter El Nino on weather phenomena across the world. So it's better to call, better not to call El Nino current, although in UPSC you can write it because it is accepted in India. Now let us come on to next, that is currents of Indian Ocean. I'm trying just. It is not changing. I'll try next class. I will change the color to white. Some people are having difficulty. So Indian Ocean. Indian Ocean is the only ocean, in fact North Indian Ocean is the only ocean that does not have any particular current throughout the year. North Indian Ocean happens to be the only ocean in the world that does not have any particular current throughout the year. This is equator. This is North Indian Ocean. Why? Because of reversal of wind. Because of reversal of wind, North Indian Ocean does not have any particular current that exists throughout the During winter season, we all know it is winter as of now. During winter season, North Indian Ocean is under the influence of northeast trade winds or northeast monsoon or winter monsoon. It is under the impact of, sorry, this is not equator. Equator is this. This is equator. This is equator. North Indian Ocean is under the, during winters, it is under the influence of northeast monsoon. In accordance to the northeast monsoon, the surface water also moves from northeast in Bay of Bengal and Arabian Sea. In Bay of Bengal and Arabian Sea, the surface water also moves from northeast to southwest. बाकी ओशंस में हमने देखा अंडर द इम्पैक्ट ऑफ नॉर्थ ईस्ट ट्रेड्स वाटर मूव्स फ्रॉम ईस्ट टू वेस्ट बिकॉज द एक्सपेंस वाज मोर in northern part because of small size of Bay of Bengal and Arabian Sea, water exactly follows the wind direction. During northern winters under the impact of northeast monsoon, the surface water flows in the direction of prevailing wind in Bay of Bengal and Arabian Sea from east to west. This is known as northeast monsoon drift or north equatorial current. Its extent is said to be from Andaman Nicobar Island to Somali coast. North equatorial current extends from Andaman Nicobar to Somali coast. It exactly blows in the direction of northeast monsoon, northeast to southwest, and it follows the projecting coastline from Andaman Islands to Somali coast. Here along Somali coast, this warm water piles up. This in winters, this warm water piles up. As a result, along the eastern coast of Somali, you find warm current. It is warm. It is warm. Warm water piles up along the Somali coast, and along the Somali coast, Somali current is warm current. During winters, हालांकि इसको उतनी तवज्जो नहीं देते, along the coast of Somali, the current is warm. Now, this north equatorial current, after reaching equator, it takes, after crossing equator, it turns towards its left. It turns towards its left in accordance to Coriolis force, and the coast of Africa also aids in this. After reaching equator, entering into southern Indian Ocean, the surface water of north equatorial current turns towards left under the impact of Coriolis force and as well as coast of Africa, and moves east from Zanzibar Island to Sumatra. It moves east. This is known as counter current. So counter current in a way receives its water from north equatorial current. This is the scenario during northern summers. Counter current extends between Zanzibar and Pemba Island in west to Sumatra Island in east, counter current. And north equatorial current extends between Andaman Nicobar Island in east, Somali coast in the west. This is the scenario prevailing in winters. Let come summers. During summers, all this disappears. North equatorial current disappears, counter current disappear. Why? During northern summer, the entire North Indian Ocean is under the influence of southwest monsoon. It is under the influence of southwest monsoon. Surface water moves from southwest to northeast. So this north equatorial current or northeast monsoon drift disappears. It is replaced by southwest monsoon current, which is strong. So this disappears, this current disappears, it is replaced by southwest monsoon. It was the water of northeast monsoon that was contributing to counter current. When northeast monsoon current has itself disappeared, counter current also disappears. During northern summer, it completely disappears. And along the coast of Somali, the southwest monsoon winds cause huge upwelling, and Somali current is cold current during summers. सोमाली कोस्ट आज पायरेट्स से भरी हुई है, एक जमाने में टूरिस्ट से भरी होती थी, बिकॉज इन समर्स कोल्ड वाटर अपवेल्स, इट ब्रिंग्स रिलीफ, और इक्वेटोरियल रीजन के पास में है, लेकिन अब क्या करें, सोमाली पायरेट्स इतने आ गए हैं कि वो, तो दिस southwest monsoon current drags the water and cold water upwells, and this Somali current becomes cold current. It is the only current in the world that not only reverses its direction but also changes its nature with changing season. Somali current. हालांकि हम cold current को ही Somali current कहते हैं. Although in winters it is warm, most welcome. In summers it is cold, and it reverses its direction. But scenario in southern Indian Ocean is somewhat fixed. Not much change takes place. South equatorial current remains in existence throughout the year. In southern part of Indian Ocean, picture is somewhat same. The south equatorial current remains in existence throughout the year, but it is stronger during northern summer, because northern summer southeast trades are stronger. By northern summer में southeast trades will cross equator and move. Southeast trades are stronger, so south equatorial current remains in existence. North equatorial current की तरह नहीं, winters में तो है, summers में it disappears. It is replaced by southwest monsoon drift. South equatorial current remains in existence throughout the year. It extends from Australia on east and Africa in west. South equatorial current, it remains in existence throughout the year from Australia to Africa. Although it is stronger during northern summer, because southeast trades being stronger. A part of its impacts on Madagascar and turned south. Remaining impacts on main African mainland and turned south. This branch which turns south between African mainland and Madagascar, this is known as Mozambique current. Mozambique channel है ना ये, this channel is Mozambique. Mozambique current, this. But the current that moves south to the east of Madagascar is not identified by any name. Locals call it Madagascar current, but internationally it has not been named. This current which turns to the south to the east of Madagascar, as well as this Mozambique current, further south, these two currents merge together. They join together and form Agulhas current. Agulhas, the most widely studied current of Indian Ocean. Agulhas current. These two join to form Agulhas current. Now, by the time it reaches the Durban coast, it comes under the influence of westerlies. Agulhas current comes under the influence of westerlies. Westerlies, as a result, it takes eastward turn. As a result, huge upwelling takes place along the Durban coast, and that is the precise reason why Durban coast is known for fishing. It takes eastward turn, and under the influence of westerlies, it blows from west to east. And just like in Pacific Ocean, it is also known as west wind drift. This word drift is not correct, neither in Pacific Ocean or Atlantic Ocean, because this is not a slow moving current, it is a fast moving current. West wind current, it should be named as west wind current. Encountering the southern tip of Australia, a part of it branches off towards north. known as West Australian current. Here it comes under the influence of trade winds. It comes under the influence of trade winds, which causes upwelling. As a result, West Australian current is cold current. Warm, Agulhas current is warm current. It is the result of culmination of two branches of south equatorial current. It is a warm current. Why Australia is a big desert? See, reason lies here. See, if you see Australia, Tropic of Cancer passes through the middle of Australia. As a result, subtropical high pressure belt lies over Australia. Tropic of Capricorn passes through the middle of Australia. So subtropical high pressure belt lies over here, which causes sinking throughout the year. Secondly, from the eastern side, the East Australian current, which causes heavy rainfall, but the Great Dividing Range does not permit these moisture bearing winds to penetrate inwards. Only the coastal area receives rainfall, not inland, because it is prevented by Great Dividing Range. In the west, this offshore trade wind that causes upwelling of cold water, which causes West Australian current, offshore trade wind does not allow rainfall. These are the three factors why Australia is a big desert. So this was about ocean currents, and if you have any doubt, you can ask it, or else we are moving on to next topic, that is tides. Your responsibility is to explain how ocean currents plays an important role in impacting the ecology, economy, and lifestyle of people, or how ocean currents plays an important role in affecting the vegetation, climate, and economic activity of the region. Yes, it's very simple. You can do it if you have seen the climatology also, because in planetary winds I explained all this, and the impact. Ocean currents are the result of impact of planetary winds. So now let us move on to new topic, tides. नहीं बेटा, how to tackle the question where UPSC gives gives another name for the same topic. The tornado and twisters are different entities, entirely different from cyclones. Tornado and twisters, they occur in arid areas, continental areas. Okay, you ask me on WhatsApp, I will explain you, no issues. But your question should be complete. How to tackle that question where UPSC gives another name for same topic? No, you cite me some example, then I'll explain you. तुम कोई एग्जाम्पल देके बताओ कैसे, तो मैं बता दूंगा. टाइड्स. Now, tides are what? Tides is a phenomena where the sea level gets raised under the impact of tidal force of sun and moon. What are tides? Tide is a phenomena which refers to rising of sea level, rise and fall of sea level under the tidal impact of sun and moon. This is a planet. Tides refers to rise and fall of sea level under the impact of tidal force of moon and sun. Here's very important one thing to make you understand. Tidal force is entirely different from gravitational force. I'll prove it. I'll explain by example. Tidal force is different from gravitational force. The tidal force of moon is far more stronger than sun, but the gravitational force of sun is far more stronger than moon. Why? I'll explain it just now. Tidal force is inversely proportional to cube of the distance. Gravitational force is inversely proportional to the square of the distance. Moon is far close as compared to sun. Since tidal force is inversely proportional to cube of the distance, because of more distance from earth and sun, the tidal force of sun is far less. 11:5 का ratio है. The tidal force of moon is 11 and that of sun is 5. 11:5. But gravitational force is inversely proportional to square of the distance. Because of might, because of weight of sun, the gravitational force of sun is far more than moon. Now see, the earth is rotating like this, west to east. Moon is also revolving around the earth from west to east, but the rate of earth's rotation is very fast, so moon lag behind. Now suppose moon is over a particular meridian. The place which is exactly below the moon is known as moon's meridian. Rising of water takes place under the impact of moon, under the tidal force of moon. The tidal force is maximum at a place just below the moon. Water get raised, and as the earth rotate, another place will come below the moon. This tide will fall, another tide will get formed, previous tide will fall, and when the tide falls, water moves in horizontal direction. That is known as tidal stream or tidal current. When earth is rotating continuously, different points are coming below the moon, different meridians are coming below the moon. As a result, what is happening? Whichever meridian is below the moon, water gets heaved up under the tidal force of moon. As it moves away, another point comes below the moon where the water gets heaved up, water gets raised, and as it moves away, it falls down. When it falls down, water have horizontal motion. That is known as tidal stream or tidal current. But these north-south extending continents create obstructions. They create obstructions. That is what we are going to study in detail. They prevent the, अगर देखोगे ना तुम्हें ऐसा लगेगा precise, it should be ideally a east to west flowing current. Tide should be raised sea level, moving from east to west. But the north-south extending continents creates obstructions. Now, first and foremost, the most important question in mind is, there are two high tides. Why does the sea level rise? Under the impact of tidal force of moon and sun, and moon's tidal force is more important, and there is only one moon. At any given point of time on Earth's surface, there are two high tides and two low tides. And within 24 hours, every place on Earth experiences two high tide and two low tide. Matlab, why there are two high tides when moon is one? दूसरा सन कराता है क्या? नहीं. It's not that. Basically, here you need to understand a concept जो बचपन से तुम्हें गलत पढ़ाया गया है. Since childhood, we have been taught that Earth revolves around the sun and moon revolves around the rubbish. Not that. बचपन में पढ़ाएगा लाइट सीधी रेखा में चलती, गलत है. Moon does not revolve around the earth, neither earth revolves around the moon. That is the wrong concepts we have been taught. Why there are two high tides at any given point of time on earth? There are two high tides and two low tides, and every point on the earth's surface experiences two high tides and two low tides in 24 hours. This was explained by Newton. उसके बाद आज तक कोई explain नहीं कर पाया. He gave his equilibrium theory of Newton, where he explained why there are two high tides at any given point of time and two low tides. He explained this by way of his equilibrium theory. Suppose this is Earth, this is Moon, this is Earth center, this is Moon center. Suppose this distance is r. Now, for this size of Earth and this size of Moon, ideally this distance should be very large. मतलब अगर ये Earth है and this is Moon, ये इससे भी ज़्यादा है. This distance should be very large. मतलब I will explain you why. this is distance from Earth center to Moon center. He presumed the mass of Moon to be m, and he took the mass of Earth to be unity. कुछ भी रख लो constant. Then the gravitational force exerted by the Moon at the Earth center would be mass of Moon into mass of Earth upon square of the distance. That is the gravitational force. I am not saying tidal force. Gravitational force exerted by the Moon at the Earth center is m upon r square. Right? Now suppose you are Moon and this is Earth. Distance from Earth center to Moon center is r. Now suppose this surface is A, center is B, this is C, this is D, and this is E. What is D and E? Now my two fingers, exactly this inside the Earth center is there, a circle around the center, these 2 points. The distance between these 2 points and the Moon center will also be almost r. ये दोनों points है ना, D and E are which points? These points. The distance between Earth center and Moon center, as well as these 2 points, and the Moon center will also be r. Will also be r. But the distance of the surface of the Earth that is facing towards Moon will be less. Suppose the radius of Earth is p, then this distance will be r minus p. This surface will be closer to Moon, and this surface will be further from Moon, r plus p. Surface A of the Earth, which is facing the Moon, this will be closer to Moon by Earth radius. ये वाले पॉइंट हैं, ये 2 पॉइंट हैं, ये डिस्टेंस तो ऑलमोस्ट r होगी. The gravitational force exerted by Moon on the surface A will be m upon r minus p. This is the force exerted by Moon at A. At C, the gravitational force exerted by Moon will be r plus p whole square. At these places, the distance is r, the gravitational force will be m upon r square, m upon r square, m upon r square. Now, Moon is not revolving around the Earth. It is a wrong concept. Possibly नहीं है. For your personal experience मैं दे सकता हूँ. Take a 5 kg ball, tie it with a rope. उसे एक रस्सी से बांध दो, and revolve the ball around yourself. Revolve the ball around yourself. When accurately measured, the person who is observing you will find that both ball and you are revolving around a common center of gravity, which is always closer to the heavier body. So much so, mass of Earth into this distance and mass of Moon into this distance should be equal. Actually, Earth and Moon both revolve around a common center of gravity. एक पेन से समझाता हूं. It is somewhat like this. जैसे suppose this is Earth, this white portion is Moon, and this point is center of gravity. both Earth and Moon are revolving around this common center of gravity, remaining exactly opposite to each other. This is Earth, this white is Moon, and this common center of gravity is always closer to heavier body. Actually, both Earth and Moon both are revolving around this common center of gravity. That means Earth is also revolving. Therefore, Newton said, when any body is revolving, a centrifugal force acts on it. A centrifugal force acts on it. And if Earth is revolving, they always remains opposite to each other. ऐसा कभी नहीं होता कि like they are as if they are tied with an iron rod. Earth और Moon you revolve कर रहे हैं ना. Moon's gravitational force is directed towards Moon, है ना? And Earth is revolving. Since Earth is revolving, the centrifugal force will always be directed away from the Moon. Earth is also revolving around this common center of gravity. So centrifugal force, Earth है ना ये revolve कर रही है ऐसे. तो ऐसे revolve कर रही है. So centrifugal force will always be directed away from Moon. Moon की gravitational force will be directed towards Moon. And because of Earth's rotation around common center of gravity, the centrifugal force acting on Earth will be directed away from the Moon. And Newton calculated this centrifugal force, and he said its magnitude is m upon r square, and it remains constant. It acts on every place on Earth. It is exactly equal to Moon's gravitational force on Earth's center. Newton calculated that the centrifugal force acting on Earth, which is because of Earth's revolution around common center of gravity, it is always directed away from Moon, and its magnitude is m upon r square, and this force acts on every place on Earth because of Earth's revolution. So centrifugal force m upon r square, its magnitude is same everywhere. It acts as every place, m upon r square, m upon r square. Centrifugal force, its direction is always opposite to Moon's gravitational force. So this tidal force is the difference between Moon's tidal force is the difference between Moon's gravitational force minus centrifugal force. अब हमें इस पॉइंट पे टाइडल फोर्स पता करनी है. तो फाइंड आउट व्हाट इज मून्स ग्रेविटेशनल फोर्स. दिस इज मून्स ग्रेविटेशनल फोर्स m upon r minus p whole square. What is that centrifugal force acting over here? m upon r square. m upon r square. इसको कैलकुलेट करने की जरूरत नहीं है, इसे याद कर लो. 2mp upon r cube. The tidal force and this direction, this is greater in magnitude as compared to m upon r square. The gravitational force of Moon is higher than centrifugal force. As a result, the bulging of sea will be in the direction of Moon. A high tide will be formed just below the Moon's meridian. And its magnitude, tidal force, you see, it is inversely proportional to the cube of the distance. 2mp upon. If you come at the center what we see, both are equal. Both are equal. Here again both are equal. But on the opposite side, if you want to find tidal force, subtract Moon's gravitational force and tidal force. Here tidal force happens to be larger, minus 2mp upon r cube. Minus indicates that it is directed in this direction, because m upon r square is bigger than m upon r plus p whole square. As a result, a high tide will get formed in a direction opposite to moon, exactly opposite to moon's meridian, but that will be in opposite direction. Now, suppose this is Earth, moon is in front, a high tide will be produced here, and a high tide will be produced exactly opposite to this. At these two places, to cause this high tide, some water will move towards this side. To cause the high tide on the opposite side, some water will move towards opposite side. At D and E, the sea level is lower than mean sea level. Sea level gets lowered. Or in technical way, you can say, since gravitational force of moon balances the centrifugal force, the resultant force is directed toward Earth's center. Or in normal language, you can write, because at D and E, surface water, some of the water will move towards moon's meridian here, rest will move towards opposite to moon's meridian. Here at D and E, the water level will be of sea will be lowered. That is low tide. This is why we have two high tide and two low tide at any given point of time. This point will move, another point will come below the sun, are two high tide and two low tide. This point, since Earth's rotation is very fast, this will reach here after 6 hours. Further, after 12 hours, it will reach here. After 18 hours, it will reach here. After 24 hours, this point will again come in its original position. In 24 hours, this place will experience high tide, low tide, high tide, low tide, and again, nahi. Moon is also revolving. This place is below the moon. Earth rotates very fast. It has just experienced high tide. After 6 hours, it will experience low tide, then again high tide, then again low tide. And by the time it will come back to its original position, moon would have moved ahead. So in 24 hours, every point experiences two high tide and two low tides. It will take 50 more minutes to come below moon's meridian. So the high tide of next day lags by 50 minutes. Every place will experience only two high tide and two low tide. जब तक ये वापस अपनी जगह आएगा ना 24 घंटे में, moon will move ahead. So the high tide of next day will occur after 50 minutes once it again comes below the moon's meridian. So high tide of next day will lag by 24 hours. So this was the basic introduction. Rest we will continue in our next lecture, right? That is, what are the various causes or various types of tides? That is, they basically tides, celestial position when moon is in syzygy, moon is in quadrature, how it causes spring tides, neap tides, equinoctial spring tides, absolute maxima, monthly high tides, monthly low tides, annual high tides, annual low tides, and then various theories explaining tides. So you can tomorrow you will again meet at the same time, and if you are enjoying the class, kindly send the feedback. यार ऐसा है ना